Hiya, this is a catch up, filling you up to speed, sorry, everything else. I'm ill at the moment. I've come back off my holidays and things haven't been too good. I have, hopefully after this, I've done as much of a video showing you about this and some of the other bits, but I'm sorry to say that's going to be it for the time being. I am off for a major operation soon and I don't know what the outcome's going to be, whether it's going to be good or bad. So I just at the present just want to say thanks for everyone for watching. Fingers crossed, I'll be back doing some more, but in the time-honoured British way of doing things, we do apologise for any inconvenience we have caused, and normal service hopefully will be resumed as soon as possible. I'm now going to leave you with, I think it's about 45 minutes, it's a bit long-winded, isn't everything? We'll see how things go. Anyway, fingers crossed, I'll catch you all, might be a couple of months. See you for now. Well, we've done all our other little bits. Oh, let's get it in camera. I ended up doing a little bit of recording on my phone, if it turns out, because I forgot to have this camera here. This is a little nylon pip. It's looking a bit mucky. It fits in there, fits on the column. There's little slice marks in it. It's supposed to be a bit of cushioning for when this column sits on top. Like I say, the markings, I'm going to do the markings, these need marking. I say I've Loctited these in now, and there was a couple of little grub screws as well that had some little hardened pins put in. I've not cut these down to size yet. I'm going to make a little holder out of aluminium, just put them in, split collar, and I can nip them off just at a later date, just little bits. What I'm going to try and get on with now is the spindle, the actual spindle that fits in this. Have a look. Obviously goes through the housing that I did. Now this is the outer, what do they call it? This is it here. There's the pulley side, there's the wheel side. You've got your inner spindle actually. What will they call that? It says 412, that's an arbor. 400, that's the spindle, and this is 401, this is the spindle body that we'll be doing next. Now, it does say out of 1.5 mile steel. I've been through the box, I can't for the life of me find something 3.5 inches, 3 3/4 inches long, so it would have to be about 4 inches long. I don't think I've used it for anything else because I can't find anything else I've used it for. I've made my arbors out of material that I've got here. So I have this. It's either mild or possibly EN8. It'll do. It says free cutting mild steel for the body, but it'll be a little bit harder. I think this will be EN3, which will be mild. Now this has 2 bearings in, 2 AC bearings. I think they're AC bearings. 408 mag bearings. I think they're AC bearings, just like I say, you can take the slack up out of them. Now this end, it says they are clamped to the body, the spindle body and the spindle, which in other words to me means that they're pressed in or slightly tapped in. Anything more than pressed in I think will won't be doing them any good. This end, the inner race is tapped onto the spindle. The outer race has, so I think it's supposed to be almost like a slide fit. You have a spring inside here that I think I've got to make, I'm not too sure. And then you can take the tension up with it, as I'm understanding the instructions. Yet there is this little blue line, if you can see this faint blue line. Now that's a sleeve, and that's on the inner races. So the inner races will be a fixed distance. That outer race will touch that wall, that'll be fixed. Yet this outer race will have this spring adapter in, and I'm assuming there's a little bit of play. It says, it does mention in the book there, you can just take a bit like M-float up, and it does assist it for when it warms up, cools down. It's supposed to keep a constant pressure on the bearings. Now we've got some very fine threads on either end here. I think I mentioned before what I am going to do, these end caps on either end as well, obviously for the thread, but I'm going to cut first off just to size. I'm going to I think it's 32mm by 0.7 or the imperial equivalent, whichever you want. It does mention something in here. It goes on about having a spring box, like I say. Yes, it mentions something. Yeah, you use magneto bearings, and it tells you about putting it, the length of material they give you, turning it between centres. Well, I won't have to, as long as I get the thing. I'll drill it out first, relieve it all, but as long as I get it running parallel, part it off, I'll leave as minimum as possible, and hopefully nothing will distort. We'll soon find out anyway. Trying to find where it says about the thread. It does mention somewhere about the thread. Can't think. Never mind. We shall get on with it. There we go. It's 32mm. Let's click you back on. It's 32mm by 0.75 or 1.25" by 32 threads per inch. My lathe will do either, so I'm going to, I have got some tips, some fine metric tips, so it's going to be by 0.75. What I'm going to do first, I'm going to turn myself down and make myself a gauge for a male gauge for the thread, and then when I screw cut the body, I'll use the gauge. I'll obviously have to touch on, go down my nominal depth. I am using indexing tips, so they will top out. Obviously get to the crest of the thread. I will go down the fixed amount, and then the inner thread will match the bung that I've made, or the gauge I've made. Then obviously when I make the end caps will then be turned to make sure that they screw into the body. So it's a little bit of customization in a sense, but that's the only way I can think of doing it. There's no fine threaded nuts for this kind of thread. It does mention it's a kind of custom thread, a very fine thread. So the first thing to do is get a piece of material in. I am going to relieve it through 5/8, and then I am going to turn it, get a centre in the end. I'm going to turn the end ever so slightly so it's not rough, and I'm going to do the OD, the full length, and attempt to get it as parallel as possible. Anyway, let's get this thing on the lathe. Right, I've got this piece of material now. I've gone through it with the 5/8 drill just to relieve it. I'm just going to skim the face up as much as what I can here. It's long enough to hold I'm not bothered if the centre isn't true at the moment. What I want to do is take a skim, get it parallel from there to there, and then I'm going to work down to the size. I think it's 1 3/8, but it's going to be a finished side for a good slide fit in that top bracket. And then, like what it says in the instructions, I can work then holding this, clocking it up either end. It tells you to flick it up to length. It's done in a 4-jaw with an arbor on smaller lays, because you obviously can't get it down the spout or anything. This will be perfectly fine for what I'm doing. So we'll get it down to size. Right, we've altered the centre a few times. I managed to get, I'm aiming for 34.9, but as you know, there's a bit of lapping needs to be done to make it fit. So I've got 34 point, just over 34.93, nearly 5. And 34.94, so there's a little bit of lapping to go on now to get the bracket to slide on. Right, so obviously a bit of lapping in later on, and this is the bracket fitted on there. And yes, it does go on both ways. That's quite good. I'll have that. I shall just go over that with a bit of Scotch Brite, because it was nicely shiny before. Yeah, we all know what we mean by lapping in, but there's that much going on at the moment about these things getting near there and out of all this that well, it's done now, so I can take it out, get some soft jaws in, and the next thing to do is flick it up to length and start looking at boring one end. I'm going to do it lightly because the OD is now finished. I mean, in essence, it is held in there, and then the spindle goes inside it, but even so, I don't want it to grow, shrink or anything if I can help it. I left it long enough after I drilled it, cooled it down, and it's quite cool now anyway. So a little bit of polishing, then on with the rest of it. Now I have made sure before I took the final cut that this was running true in me soft jaws. I use soft jaws, as you probably know, 4 jaws if it isn't round, but that's just me. So I checked that. I will now put this in the other end. Bit long-winded, I know, but I will clock it up, take a skim off and repeat until I get down to 3 3/4. So I'll see you when I've done that, and then I'm going to let it cool for a while. And what I'm going to do now, I've set a boring bar up. This spindle sleeve is recessed at either inside either end, about 2 and a bit inches down to 7/8. Then it's the other side is for the spring box, but what I'm going to do is lighten it all out first and then leave it and let it kind of relax, cool. Hope it's not gone anywhere. There should be, if there's going to be any distortion, less distortion. So all I'm doing next up, I'll show you once I've done it. I'm just relieving it, leaving it 1/2 mm or something shy. I'll do the other side. I'm not bothered about clocking it up because I'm not finishing anything yet. I'm just making 2 relieves on either end. Hopefully if there's any stress in it, it'll take it out. Right, I've had a long and hard think about this spindle body and the spindle. Yes, I know, there's jokes like I thought I could smell something burning and good God, what did you do in the afternoon? But anyway, this spindle body and these caps on the end. Now, I've done the spindle body, I've roughed it out, and I've done the counter bore, the big counter bore. I've left a millimetre in it, millimetre in that. I took it down to depth. No, -4 thou, I think. Just left off 4 thou. And just left it, let it normalise. Now, it's going to have these threads in either end. I am going to make myself a gauge. What I'm going to do is, it doesn't explain it in here, but if you look at this drawing, it's very well when it says about these labyrinth seals here. You will, what is it? They cannot be built, cannot very well be built up. A tool of a maximum of 6/5 thou width is required. That's all well and good. If you look here, he's got a nice indexable tool on a holder with a carbide end by the looks of it, that's all formed up and ready. I haven't got one of them, so I'm going to bloody well make one. It's 4.9mm deep, that. I can see maybe a couple of attempts at this, but anyway, looking at that, it looks like it's then been screwed into the body when it having this side done. It doesn't mention anything, but looking at it, and if you think about it, you put your body into your chuck, you can see on the drawing here he's got some very fine pieces of maybe copper or something. He's tapped it true, got it true in a 4 jaw, looks like a 6 jaw in there possibly. But he's got that outer spindle body running true. He's screwed these in. Then I would say, looking at it, if you finish turning off the bore of these, they call them lock nut covers, and put the labyrinth seals in there, they should effectively be running fairly true with this body, because you've got 2.5 thou clearance in here. How the labyrinth seal works, this spindle slides in slots. This slot here, it's sliding over it, and it says it will run but when you actually look at the sizes, you've got about 2.5 to 5 thou clearance, which isn't a lot. And I would say the best way to do it, to get it as concentric as possible, is the same as them. I'm going to do a dummy one of these now with a male thread, and I'm going to just do it to size, and then I'm going to screw cut this to the dummy I've made, or the gauge, whatever you want to call it. And then when I screw cut these two, I will use this as a gauge against them. Hopefully both ends will then fit each other, and then I think I'll be doing what they've got on here, is finishing them off and this groove while it's held in the body. I don't really want to, because I don't know how much strain or anything else it's going to cause when I start to do this groove. I'm going to have to be very, very careful, because I don't want to put any pressure on these threads, and I don't want it to lock up either. But I might just have to give it a go and see what happens. Anyway, we'll crack on, see what turns up. I've got this piece of free cutting mild steel for making these locking nuts at the end. Clocked it up with inside a thou. It does run luckily with inside a thou. Rough board, so I'm going to first off rough this out, and then I'm going to turn it to size. It's a 32mm by, what's it now, 0.75. I'm going to try and turn it about 02 under 32, and then I'm going to do my other one the same. I have got indexable tips, so I'm going to use my DRO and go down to the full depth of whatever 0.75 pitch is, and then that will be it. That will be used then as a gauge. But like I say, I'm also going to turn it. I'm going to finish the bore just shy of the finished bore for one of the locking rings, so I can also use it as a backup as well. And I will try and have a practice with it when I do the face groove on the other side. That's the plan. And I'm going to put a nice little undercut just in here, just a milli back, just to clear it. Go down to the core of the 32mm with 0.75. It's about 0.92 of a mil, so I'm just going to go down a millimetre and take it down to 31. Well, I've got my compound set up at 60 degrees. I've checked it with a protractor because I don't trust these marks on here, because I know they're out. And I've got a very, very small indexable tip in there, 0.75 for this pitch. Now, my lathe does do 0.75, but it says opening that the gears should be a 30 to a 40 tooth. Now there's your 30, that is definitely not a 40, that is a 60. That gives me a lot finer thread. Now shut that. Instead of swapping the gears around, I probably mentioned this before, I've used this software. Let's just go back onto the table. I've used this algorithm that is Ride the Gear Train by Evan Lewis. I think that's right. Evan, if it's wrong, I'm sorry. Now, you put all your data in there. I might have mentioned it a few times, like I say, and you put your wheels in, your gear, your driven, your driver, your driven, if you've got anything in between, compound gears. And I did this a while ago from 0.5 to a 5mm pitch, just for the fun of it, at 0.25 intervals. Now if I hunt through for a 0.75, and it gives you all different gears. Where are we? Oh, sorry, I'm in the wrong place. No, that's carrying on 0.7, but there's loads of the damn things. We start up here. Now, I'm looking down here. And we start on this page, actually. That's what I mean. I've got about 20 odd pages in here. There's loads of them. Now, as I go down 0.75, my driven is a 30. It says any two for the idler, and that's a driver, sorry. And the driven, there's me 40, but there's a 60. And it also tells you on your gearbox, and I've forgotten how this is worked out. It's beyond me. I'm just following what I've got down here. What it says, set it on the gearbox, and what actually the gearbox it's set to. So we go back, and it says if I'm on a 30 any idler, which it doesn't matter, and a 60 ACR 3, it's 1.125. Get rid of that. There's me 125 there. AC R3. Now, to double check it, I've got this in gear now, and I put a felt tip mark there, and I've got my Z set at 0, and I've got this engaged, and I've took the backlash out. So I'm going to turn it by hand, come up to 1 revolution. Alright, I've got 0.73. I might be a little bit out with me revolution, but if you think that's 0.015, you know, I might be a touch out with that. It hardly makes any bloody difference. So that's right with that. I'm not going to argue about 0.015. I think it's probably just where I started it off from. So I'm going to touch on, I am about 02, 03. I'll check it again with the mic underneath. I'll get a scratch on, and then I'm going to go down to the depth of whatever 0.75 is, and I think it is about 0.9 something on the diameter. So anyway, I'm going to set it all up and get ready for that. Right, now that is just scratched, and I mean just. I actually touched on with a piece of a energy bar, and I was 07 off then. Right, now looking in the old Zeus book, got 0.75 pitch there, and the depth is 0.46, so double it up, it's 0.92. So I'll set my DRO to 0. I'm going to go in 0.92, reset my 0, and come out on my compound. What we got? 0.4, just over half a mil. Now I'm going to do a couple of very slow passes and just increase by about 0.2 until I just begin to touch. Now I put myself an undercut there. Now, how do I know whether we're the right pitch? I'll have a look. Well, looking at that with a magnifying glass, it looks right. We're going to assume it's right because it's like what it says in the drawing. It doesn't really matter as long as it's a fine pitch and you do everything to the same setting. So it looks right on that. I'm going to go down to depth and then use this as a gauge, and as long as I do the female threads and the other two threads, the exterior threads, external, to the same gearbox setting, effectively, even if it's not 0.75, which it looks like it is, it should all fit. So another little check. And that is so fine. And I'm looking with this, but anyway, I'm not going to carry on. I'm not even using any coolant, and as you can tell, I'm not disengaging my lead screw. I'm just putting it in reverse. I've got a good enough undercut there. I'm coming back to 0, and I'm only taking very, very light cuts. I'm getting close to the final cut. Now what I've done as well, I made sure with my micrometer I'm still at just under 32, so I've not crested that thread yet. Because technically with me having these tips in, and if they're ground proper, when I get to size, if I go a little bit under, it should crest and take a little bit off that thread. Well, that's that done. Right, now I've got the spindle body put back in. It's running less than half a thou with the clock I've got. That's as true as I can get it. I think it won't do any better, but anyway. Now I've not turned my compound back round yet from screw cutting. There's no need. I'm going to bore this out. That's a square face on there. It's either square or a little bit back. Now it tells you to take the outer race of the magneto bearing. He said it's not very good practice, but this is what you want to do. You might as well use it as a gauge, and it's supposed to be just a sliding fit. Not an interference fit, but just a sliding fit for the outer race to slide in. It's about 11.9 down here. Now on the drawing, it's got the face and it's got a chamfer, so that the outer race, the end of it, the outer race, and this clearance so the inner race doesn't touch. Now on the other end, it's got a step. So I don't suppose it really matters either way. If I do, I'll get you the race. if I come up, just clear that and then do a step back, rather than put something in and make a chamfer, it isn't going to make any difference because the chamfer's at 45 degrees, so there's nothing there. So if I actually come back and do it like that, square, excuse me, it's not going to make any difference as long as that sits against the shoulder and there's a little bit of clearance at the back, so the race, nothing in the race touches, because the spindle's going in this way with the head of the spindle out here. So I've got to do the recess for this, then the core of the 32mm thread. Now I've worked it out, it's 31.07 or something or whatever, so I shall go for 31. I'll do a little undercut to 32, or just a 32.1. I mean, if you take into account 1.5 times the pitch for an undercut, it's 1.12. So if I just do just over that, I might even try it with this, then I've got a little chamfer at the end. Then I'm going to turn my compound round this way for screw cutting, and that's all going to be off the DRO. Anyway, we'll see how we get on. I've just done some re-tapping, a little bit of tap on the spindle, and it's hardly moving the clock, so that'll do. Right, now there'll be lots of different ways of setting tools up. Mine might be the same as other people, I suppose, but well, it's got to be, because this is how I was taught of other people. This is why I made my adjustable scribing block all them years ago. Set off my centre, of course assuming your live centre's centre with everything else, and we have in here an indexable 0.75 ER11 sorry, NR internal, and I've lined it up with best magnifying glass because I can't see that close with or without glasses. Right, so that's there. I'm now going to square this up with my chuck. I'm going to mark that up and get a touch on, and it's going to be off the DRO from the end of the tip to the end of where the thread is. Fingers crossed, let's see how it all goes. Right, let's get you a bit nearer. Now, the nature of the beast of this is I have just touched on and got a scratch, and then I've gone that way to what would be the depth of my thread. I've also touched the tool on there, knowing what depth I've got in Z. I will be running as slow as possible and up to it. Now the tool is formed at the end, and if I can get it as close as possible, this is just going to be a, like I say, touchy feely thing, and we'll just have to see how we go. I'm also going to cut as slow as what I can and run off the DRO. Once I've got a setting, I shall set a 0 on my handle on my Z as well on the saddle, just to be on the safe side. This is so much fun on a Friday night. 1, 2, 3, 4, 5, and nearly where it should have been. First try, bit tight, carry on. Just done a little bit more and we get in there. I reckon it's pretty damn close. 3, 4, 5.42. Obviously, like I say, I'm keeping it in gear all the time, just the way I've screw cut for ages, and if the machine can do it, which it should do. So you've got to be very, very careful. I tend to move whatever I'm putting it in backwards first off, until you feel it kind of engage or slot in there. Ooh. So let's come out a bit. Now, that feels good to me. I am over the moon with that. Absolutely over the moon. Now then, all I'm going to do is a little bit of Scotch-Brite round there. I'm going to make sure that my outer race still goes in, but that for that end, so that's me my gauge. But I am very, very happy with that. Like I say, I've used an indexing tip. I've touched on and I've gone to the depth. Now this was just under the core depth, so I obviously went past my zero for about 0.8, yeah, which is about 2.5–3 thou round there. But obviously this tip, it should crest and just take a little bit out, but I'm very happy with that. It's not ripped it, and we've managed it. All I've got to do is make sure I do the same on the other end. Well, let's adjust that. I'm set up again for doing the other side of this spindle body. Now this side goes back about 31–32 mil, and it is chambered out for a sliding fit for the outer of the magneto bearing, plus you then make a sleeve that fits in there that holds the tension springs, so that's got to be a slide fit. But first off, I am going to machine this, see what kind of finish I get. I'm going to try and take it nice and slow because I want to get this nice sliding fit, and we're talking, like I say, 30 mil down there. So we'll see what kind of finish we get. Right, that's the second one. I'm going to do one little spring pass now and then clean that up and bar a little hole in it. I think that is finished. Now I've just gone ahead and made another one of these. Exactly the same process as before, but this time I have the spindle body as a gauge. So that's down to size, plus about a couple of tenths, and obviously I might as well try it on both ends. Waste of time doing it and finding out it's a bit tight on one end. I mean, it shouldn't be, but because we use the other one as a gauge. But there you go. So like I say, exact same process as before. I'll now just clean the thread up a bit, part it and make another one. So I will have a spare one of these, but why not? Now I forgot to put a little feature in the end, these end caps, and that was 0.8 deep and come out 25.4 or an inch, and it's just so the end of the cap doesn't interfere with the inner race of the bearing. Both caps have got this on. At one end it's for something, the other end it doesn't really do anything, but I have to admit I forgot to put them on. So luckily for me, because I use soft jaws and I know how true these soft jaws are running, I've got a recess there, and I've put these in and they're running just spot on. So I can touch on with the boring bar on the bore, come out, get a vernier, .25.4. There we go, spot on.